done, seminar will have audiovisual presentations and content by industry experts. These professionals have specific ideas on how to better protect through automatic fire alarms and curb false alarms. Most of you will learn more today than you could ever believe. I'd like to introduce our speakers. Richard Beelan from National Fire Protection Association is to my left. Ron Meehan is from Mass Property Insurance Underwriters, which works with the State Fire Marshal's Office. Peter Tallman is a senior engineer at Underwriters Laboratories. BRK we're waiting for. They should be here shortly. They're stuck on the Northeast Expressway right now. We're waiting for them shortly. Myself from Wayne Alarm Systems. We also have a gentleman repping for ESL Corporation. Now, we've spoken to Tom about it, and if we can get cards from all the departments, they've agreed to give away a fire alarm system, a complete fire alarm system, so any fire department can mount it on a board and use it for training within their department. So please enjoy your lunch, and we're going to cover a lot today. Thank you. How are we doing? Before we start this seminar, our attitudes must be right. In this instance, the best attitude is that we can do something about the false alarm problem and have better protection through the use of automatic fire alarms. We are committed to this goal. This approach clears the way to creatively put together a program with the resources that we have. A fire system contains many sophisticated electronic components and some not so sophisticated. The following facts are quite revealing concerning operation expectations. The normal fire system will be on or live for a period of approximately 8,760 hours per year. This 8,760 hours represents something like 7 years normal operation of a television set, 25 years of a washing machine, and 18 years of a private car. Alarms, like all important equipment, require regular maintenance. Alarm studies reveal that false fire alarms are caused by environmental conditions, equipment malfunctions, misapplication, telephone line problems, and a variety of other errors and conditions, some uncontrollable. False alarms are costly in many respects. Fire agencies have documented well the resources they waste in answering false calls. Some alarm companies, after running similar studies, have discovered that false calls cut severely into profit margins. Equipment troubles actually relate to two basic conditions: either the system itself, its circuitry, its design, its construction, either that's faulty, or the system has been misapplied, installed improperly, or in an environment not suited for its operational characteristics. User-occupant errors result in a great percentage of false alarms also. Temperature irregularities, remodeling, construction, negligence, repairman error, power off, occupant abuse, and failure of electrician alarm company to report they are working on a particular system. Some fire departments have found that a handful of premises cause the majority of the problems. A further concern is when a tenant occupant shuts the fire alarm off due to system false alarms, or fear that the fire department is constantly going to appear. Underwriters Laboratories, a recognized standard and testing authority in the industry, defines the ideal fire warning system as one of which 1. Provides early warning and maximum coverage of potential fire sources, 2. Is not subject to false alarms, 3. Is reliable, 4. Has a long useful life, 5. Is self-supervising, 6. Is easily installed, 7. Is low in cost. Note that low in cost is at the bottom of the list. A smoke detector user should be primarily concerned with much more important factors than price, including a device which has a proven record for minimizing false alarms, a device which provides rapid detection of the type of fires most likely to occur in that particular installation, and third, choosing a detector that will provide all the functions and features necessary to meet all code requirements and special operating characteristics of the installation. Some examples of the problem are whenever there are bugs, alarms have problems. In fact, 30% of false alarms in fire systems are suspected of being caused by crawling insects. Bugs, whether they are roaches, spiders, ants, gnats, or sand fleas, can cause falsing in 3 ways: by interfering with the photoelectric beams inside the smoke chamber, by blocking relays, or by gnawing wire insulation and then depositing their highly acidic droppings, which sets the stage for shorting due to moisture or corrosion. In Beaumont, Texas, a senior citizens housing development had an incidence of false alarms from 5 to 6 at night for a period of over 2 years. It was a terrible case of cockroach infestation. During the same period, on the small island of Nantucket, the hotel industry reported 40 to 60 false alarms a month. According to the fire department, gnats and sand fleas were penetrating and breaking the beams of the photoelectric detectors. Screens of one type or another have always been integral parts in photoelectric smoke detectors for some time, but in response to the falsing problem, manufacturers have developed much finer screens. Also in response to the falsing problem, manufacturers now provide anti-bug screens and ionization-type detectors as well. It is a move which Underwriters Laboratories strongly recommends and soon may require. The second preventative product is rainbow insect tape. It resembles a Band-Aid. It is an adhesive-backed plastic strip that has a reservoir of high-strength insecticide that gradually migrates to the tape surface. Strips of insect tape may be applied both outside and inside either smoke detectors or controls. Its life potency is approximately 3 years. The product serves first as a repellent. It emits an odor which, virtually undetectable to humans, is highly offensive to insects. It also kills insects that cross its surface. In the Beaumont Senior Citizens Housing Development, which was having 3, 4, 5 false alarms on average a night for several years, has now reduced their false alarms to approximately 1 per month on average by changing the smoke detectors to a lower sensitivity smoke detector and installing the insect tape. So there are solutions. Preventive maintenance and inspection is the most economical way to handle automatic fire alarm system problems. You can repair at a small cost today a minor problem that, if left unattended, could worsen and cost much more to fix 6 months from now. This notwithstanding the possible lack of coverage the occupant to the building is receiving or not receiving. A proper inspection, whether it be from a fire department or from an alarm company, should basically cover 4 stages: a visual inspection, a system operational check, a measuring of voltage, which really is only up to the alarm company, and we don't expect any fire departments to get involved in carrying meters. And 4, an occupant consultation. The visual check focuses on the workmanship. All detectors and components properly and regularly mounted? Have the components and smoke detectors been cleaned? Is placement proper? Is the wiring correct? The second phase ensures that the system works as it was originally designed to do. The third phase ensures the system will operate in an alarm state for a predetermined time if the AC power fails. And the fourth phase is discussing with the occupants of the premise the problems associated with dust, spray painting, fumigating the premises, or construction near smoke detectors. It also discusses the procedure of what to do if an alarm sounds and why periodic testing is so important. Preventive maintenance and testing ensures a minimum amount of emergency maintenance is required. From an alarm company's perspective, improving emergency service procedures is basically a matter of better managing a serviceman's time. Many false alarms are listed as cause unknown because the serviceman doesn't have time enough to thoroughly inspect and test the system, or they just aren't given the proper information to solve the problem. The condition will usually not correct itself and more false alarms will result. In regards to installation, there are essentially 2 steps involved in automatic fire alarm system installation: planning it and actually installing the components. Errors in either step can lead to a false alarm problem. Proper planning plays a major part in eliminating both false alarm problems and giving the occupant the correct coverage they require. Proper planning starts with matching the fire protection system to the premises environment. Careful attention must be paid to the manufacturer's instructions on where to and where not to use a particular unit. Industry and fire prevention departments have uncovered some basic do's and don'ts, which we can get into later in the seminar. Many fire departments were asking for a simple form to follow whereby an acceptance test or inspection report guideline can be followed. In your packet, you'll find a copy of an inspection report that Wayne Alarm uses to follow through on an acceptance or inspection test. It follows some basic guidelines and standards from NFPA and UL. With new systems coming online, we realize it's difficult to keep up with the latest in operational characteristics and reset procedures on automatic fire alarms. Therefore, some recommendations are as follows. 1. Permanently affixed zone plate on or in close proximity to fire department, showing actual area in English and zoning showing on back the fire department permit when issued. 2. Label or sticker showing who the servicing authority is and if it is tied in for fire response. 3. Reset procedure on or in the panel unless it is self-explanatory. And 4. An alarm response log for the responding fire officer with any service done on the system. And basically that's an understanding from a perspective of an alarm company. What I'm going to do is we're going to open it up to our speakers, and our first speaker is going to be Peter Tallman, who's a senior engineering assistant at Underedge Laboratories in Melville, Long Island, New York. So, Peter, thank you.
After everything that Ralph said, I don't think any of us have anything else to say. That was quite a good presentation. I spend a lot of my time on the road traveling. I'm based in New York, and I cover basically the northeastern part of the country. And I'm involved in a number of things, including inspecting fire alarm systems. This week, in order to work my way up here, I happen to be working in the Providence area. And I had a little experience here tonight which kind of fired me up for what we're talking about today. About 11 o'clock at night, after reading my standards and so on for the evening, I fell asleep. And around 11:30 or so, the fire alarm system went on. The building was evacuated in about 10 minutes. Some of the occupants came out very slowly. The sort of procedures the hotel used were a little erratic and uncoordinated, but eventually we all got outside. 3 pieces of apparatus rolled up, about 9 firemen, a fire chief, fire prevention officer, a couple of police cars, and they started to search the building. Within a few minutes, they realized, or they were able to confirm, that there wasn't a fire and that it was an apparent false alarm. Later, in talking with the building management, I learned that the false alarm was due to a dirty smoke detector and that it happened all the time. After I heard that, I spent some more time walking around the hotel, and I could see some of the reasons why. Ralph had mentioned the placement and design of systems. The detectors were all installed, or most of them were installed, right next to supply vents of HVAC, or heating and air conditioning ducts. I noticed that several of the audible devices were loose or hanging on the wall properly. And then I recalled and confirmed later that many of the strobe lights used with the Hawthorne strobe systems weren't working at the night of the false alarm went off. So this system is really typical of the problems that the fire alarm industry is facing. The system is probably 3 to 5 years old, and although it was not quite a picture-perfect system, but certainly a well-designed or well-covered system. Once again, the placement of the devices weren't necessarily in the best locations, but all of the major aspects have been taken into consideration. There were pull stations, there were horns and strobes throughout, there were smoke detectors in all the major public access areas, there was sprinkler supervision. The problem is that the system had slowly changed over the 3 to 5 years and now was a routine failure. It was constantly going into false alarms and nobody was apparently addressing the problem. The cost of this, of course, is a direct cost of the 13-odd people who responded to the alarm, direct cost to the comfort of the occupants of the hotel, myself included, probably a direct cost to the client I saw the next day, and there was some indirect costs. The community wasn't being properly covered during the time that the fire department had to respond to this nuisance alarm. So there are solutions, and the problem is coming to the realization that those solutions have to be brought into play. Part of the reason why you're here today, of course, is because you have an interest in finding solutions, and that's very important. The fire alarm industry has grown tremendously over the last 10 or 15 years and provides a very valuable service to the communities. But the fire alarm industry has the problem of having to be able to design systems properly, working with local authorities on the codes, following national codes in addition, and having the opportunity to be able to periodically test and maintain systems. Without a periodic test procedure, without preventive maintenance, the fire alarm system will be no more reliable than a car that has never had a safety inspection. And so that's a major problem. UL's role in the fire alarm industry is really twofold. You've already seen our labels certainly around your home on household appliances, all over the place on many, many different things. The UL label has to some extent become synonymous with an idea that there is safety in the product design and there's going to be safety to the user. Underwriters Labs has used that goal as our base mark in all of the activities that we do. In the fire alarm area, though, and in turn in the burglar alarm area, our analysis of equipment also includes the operational aspects of the system, so that within the realm of burglary protection and signaling products, we are involved with not only the safety aspects, is there going to be fire or shock hazard, but also will the product perform reliably in its intended function. Intended function, of course, becomes a major factor. We got started in the analysis of fire alarm systems much in the same way that I was aroused to speak a little bit this morning about false alarms. Our founder, William Merrill, used to play cards regularly during the early part of this century with the fire authorities in the city of Chicago. Apparently they'd rotate the game throughout different firehouses. And during one game they were in the firehouse that had the receiving console for the street boxes in those days. And during the game the receiving panel went off numerous times and nobody budged from the table. So at the end of the game, Merrill turned to the fire chief and asked, well, why is this? You know, we have all these alarms coming in. Why isn't anybody being sent out? You know, what's the story? And they said, well, essentially, the systems are so unreliable that we will not respond unless somebody actually calls in or sends a runner in to confirm that there was truly a fire. The very next day, Underwriters Laboratories developed a signaling department to be involved with testing fire alarm or signaling devices in those days for their operation, for their reliability. Since that time, obviously, we've grown into both fire and burglar alarm activities, and the number of products in the market have increased dramatically. This time, I believe we publish about 74 standards in burglar and fire alarm equipment. Some of the standards that are very important these days are UL 268, which is a standard for multiple station smoke detectors, or system type smoke detectors, if you will, those that you probably encounter in all the commercial buildings that you might go out and review in fire prevention. There's a companion standard, UL 268A, which is for duct detectors. Because duct detectors have unique characteristics and conditions, we felt it was important to develop a separate standard for those types of systems. There is a standard on smoke detectors called UL 217, which is a standard for the single station type smoke detectors, which means typically the battery operated detectors you might find in somebody's home. It's very important to at least be aware of the fact that those two standards are significantly different. 268 is involved in alarm systems, whereas 217 is involved simply in single station devices. Not to say that there's anything wrong with a single station device, but its intended operation is entirely different than operating as part of a system to protect lives in a public property or in an office building and so on. It's a very big difference. Another standard that is very important in fire alarm systems is UL 864, which is a standard that's used to test control units and control unit accessories. The important element within that is when you may see a UL label on a control unit for a fire alarm system, you have to recognize, or you have to be aware of the fact that that control unit may not be listed for all types of fire alarm service, and that its testing is going to be based on what the manufacturer has asked that we review it for. So it'll be tested under 864, but the label will reflect, or labeling and internal marking within the panel, will reflect those types of fire alarm systems that that panel is suitable for. Nowadays, there are in essence 5 types of systems, ranging from central station fire alarms, to locals, auxiliary station, remote station, and proprietary. And because a panel is listed does not mean that it's listed for all 5 of those systems, and in fact, in some ways, it may only be listed for 1 or 2 of them. It really depends on the configuration of the panel and how it was listed. And this may in turn get into the types of components that are used in the system. That's a very important distinction for those of you doing plans reviews and doing on-site analysis of fire alarm systems. UL's standard process follows the American National Standards Institute guideline. Essentially, when we perceive a need for a standard in a particular product area, we will assign a staff engineer who's familiar with those types of products to develop a rough draft of the standard. The standard will then be reviewed internally with our staff engineers for comments and so on, and then sent to an industry advisory council, which is made up of companies that will be affected by the standard or users of the standard. So in the case of a manufacturing standard, generally speaking, that would be manufacturers of the equipment and perhaps some users of the equipment in the area of alarm fields. When the IAC has passed their comments, it will be reviewed by a standards council. That is a group that is assigned, or I should say is developed from interested third parties who would be affected by the standard and who sit on all of our engineering divisions to make recommendations for how we should, or areas that we should pursue. Once the council has given the standard a blessing to say, well, it seems like a good idea and the standard appears to be a good one, we send it out to the industry at large for comments. This is known as a consensus process. Our consensus process typically takes 90 days. It may take longer depending on the standard and the comments we get. At that point, every comment that is received has to be responded to in writing, explaining our position or what we're going to do with the comment and so on. Hopefully it'll be a polite response. The standard is then published, and because it follows the ANSI guideline, there's a 5-year cycle for our standards. So every 5 years we're publishing or revising a standard and developing a new edition. If there are significant changes in a particular area that require new specifications for equipment, if they are significantly or considered a high priority item, we will go to the industry and give an 18-month period of implementing that change. If it is a downgrading of a requirement or a relatively minor change to the standard, the implementation will take place at the following edition of the standard. So there's this ongoing activity within UL of the standards department and this continual upgrading and reassessment of all of our standards. As people involved with assessing fire alarm equipment, of course, verification of a listing becomes very important. And certainly the most common way of identifying a listing is by looking at a product and seeing a UL label on the product, and the label will nowadays indicate the product category under which it's listed, what it is intended for. We also publish directories, and many of you may be on our subscription list to receive copies of the directories, or if you choose to get copies, you certainly can contact us and we'll get them to you. The directories are published annually, supplemented semi-annually, and arrange products by product category and in turn by manufacturer's name. And if the label if the product is labeled 100%, there will be a model number included in the publication of the directory. So it's very important to understand that equipment listed by UL may have a wide variety of uses, and it has to be equipment that is intended to be used in the type of systems that you're reviewing, and not just the fact that it's some assemblage of UL equipment that may or may not perform as expected or perform as intended. UL is also involved in a certificate service, and in this area, this is a group within the Burglary Protection and Signaling Department. And within this group, we list alarm installation companies, or in the case of fire, alarm maintenance companies, to provide certificates to their customers indicating that the system has met certain specifications and has certain characteristics. We have basically two categories within the area of fire alarm. The first was Central Station Protective Signaling Service. That was introduced in 1966, and at that time involved an analysis of the Central Station facility and the ability to retransmit alarm signals to authorities having jurisdiction, local fire departments. In 1984, we were asked by the insurance industry in the early 1980s, and we introduced in 1984 a certificate service for Central Station fire alarm systems. I'm sure all of you have heard the term Central Station. Many of you have undoubtedly toured Central Stations and have been involved with those types of systems. But within our language, a Central Station protective signaling system is one that reports to a central station, is being tested and maintained by that central station, and complies with NFPA 71. And that includes that the equipment used is central station type equipment. Control units and so on are all central station equipment. Central stations listed under this category must be able to provide runner service in response to alarm signals and supervisory signals, to investigate the cause, bring about the repair if necessary, and so on. And also to retransmit the signal by at least two independent means to the local fire authority. So central station service in our language means that the central station is involved in all phases from the device right on through to the call to the fire department. And at this point in time, there's one sole responsibility for that entire network, and that is the Central Station Company. In 1984, we expanded the certificate service to bring out a category for the other types of fire alarm systems, essentially the NFPA 72 series systems. That is local, auxiliary station, remote station, and proprietary systems. And here, because the systems may have several parties involved in the design, installation, and ultimately turning the system into service, we actually list the company that is providing the maintenance on the system. Because we are listing the maintenance company, we require that company to assemble a lot of documentation about the system to verify that all things that were supposed to go on in the system have been done and the system is performing as it was designed to perform. So that means that the maintenance company has to develop or obtain as-built drawings depicting how the system was installed, including location or approximate location of devices, a legend indicating those devices that are being used, approximate routing of fire alarm cables or circuitry going throughout the system, obviously location of sounding appliances where that's necessary, location of control unit, and point of connection to commercial power. The company must also compile battery calculations to verify that the system has sufficient standby battery, the length of which is required by NFPA, and it varies from 24 to 60 hours. The company must also verify that all the devices used in the system are compatible. This becomes very important within the area of two-wire smoke detectors. Compatibility is a significant issue, and quite simply, if there is no verification of that, there may not be any assurance the system is going to operate. It could look great, but may not perform. Finally, the company has to provide or perform a 100% acceptance test on the system. What we regard as a 100% acceptance test means that the company must test all elements of the control unit and record the results of those. Must test all the circuits, record the status of the circuits, including loop resistance. Must test every device in the system for alarm and trouble, all the initiating devices, the pull stations, smoke detectors, and so on. Must test all the audible appliances, if they're included on the system, to verify that they work, and so on. And all of this test is recorded and is used to establish a profile, which is the benchmark for all subsequent periodic maintenance or periodic test procedures that must go on. So when a company issues a certificate under this program, they have gone in and verified that the system, on the day that they issue the certificate, complies and functions properly and so on. In order to accommodate the realm of the local authority and specific needs they may have in the design of the system, there is an exceptions area on the certificate which allows for some deviations from NFPA standards as long as the local authority is signing off on those deviations. So this exception is one that I permit within my jurisdiction. The certificate, and I've included copies in your little booklets, you can read them to your children tonight if you'd like, if you have young children, that is. The certificates in both categories essentially provide a description of the types of service, the number of devices that are installed, and where they are installed, and so on. In the area, for example, of water flow service, it would include the number of sprinkler risers in the building and the number that are supervised. And so it's that kind of relationship to give you, or perhaps an insurance company, or somebody else with an interest in the property, a very quick summary of what is involved with the system. So the idea behind these systems are they will be defined when they go into service. On the second phase, of course, we require testing and periodic maintenance to go on with the systems. Unless the local authority has superseded it and changed the frequency, we require the tests to be bi-monthly on all alarm devices and semi-annually on all supervisory devices. 100% of the smoke detectors, or I should say the automatic detection devices, tested within 6 months. And documentation of all of these activities must be held by the issuing company. The way this particular system is managed, as it were, is that every listed alarm company is subject to an annual inspection by Underwriters Laboratories. So we have field personnel, of which I am one of them, who go out to alarm companies, arrive at the door and say, listen, I want to go to these following places, here are the certificates I have, we're going to do an on-site audit, bring all the documenting records, all the as-built drawings, and everything else that may go on. In case of Central Station, that will also include an audit of the alarm records and supervisory signals that may have been received. And essentially, we'll go through the system to verify that it is still in compliance with the certificate. For a company to become listed, they have to demonstrate a working knowledge of these standards. And the only way that can be done is by constructing systems. So we require that alarm companies that are applying to us for listing to prepare systems, in the case of Central Station, that comply with 71, or in the case of the fire protective signaling, that comply with the 72 series. And essentially, they will define to us by filling out what amounts to a type of certificate defining what the system is supposed to do. We'll then go in and do an operational check on the system to see that it works as intended. What we look for in a listing is that the company is going to demonstrate several things. One, that they have all the documentation in order, that they've done all the preliminaries, and in Central Station service, while as-built drawings are not required at this time, acceptance type activity is required. And that the design of the system is correct. So then we walk into the technical side of things of Are all the devices placed properly? Are all the circuits wired correctly? On the board in the back to the left-hand side, we have some examples of the classic nose and wiring, which all too often is seen in actual installations. And so we go through that aspect to see that the company is demonstrating a knowledge of how the system should be, and how it should be designed, and how it should perform, and the environmental factors that may influence the system. Finally, we look at the system from the operational aspect, from the testing and maintenance. And we ask their technician to do a periodic test. We're not going to tell you what to do. We want to observe what you're doing and see how well they perform, and are they familiar with the requirements. A failure in these areas could result in denial of listing. A failure in these areas on an ongoing annual inspection could result in either one, the cancellation of the certificate, or two, the decertification or delisting of the alarm company if those types of failures become widespread. In order to, or some of the things that we are doing these days in order to make the certificate a little better, a little more available to alarm companies and fire authorities and so on, is that we've started automating our certificate service. We currently have a program called UL Certificate Verification Service that allows an authority to access our certificate database by number to verify if a certificate is issued, and if it is issued, get a screen display of what is on that certificate, what is covered, type of service, the issuance, the expiration date, and so on. The idea behind this program is that while you as a fire authority may be able to go in when the building goes into service or the system goes into service and look it over and say, everything is complying with our local codes, it works well, we tested it, and there it is, it's fine, without going back constantly, you have no way of knowing if the system is going to continue to comply. It's being managed correctly. A certificate gives you that assurance in that it tells you, well, somebody is going to be going back to test and going back to verify that the alarm company is maintaining it. The CVS program gives you the opportunity to find out if that certificate expired and was never renewed, thus the system may no longer comply, or if that certificate were canceled by UL or perhaps by the alarm company because of some non-compliance or some other failure. So it's a very important program, and we're offering it to fire authorities as well as insurance companies. The only requirement essentially is that they have a terminal and a modem that will give them the ability to access our system, and essentially there's no user costs involved with this particular network. So if anybody is interested in that, in learning more about that particular service, by all means ask. We'll be certainly happy to give you the information.
Peter, I think the only community around that's asking for certification is Boston.
At the moment, in this particular part of the country, that is true. Boston also, incidentally, has signed on to the CVS service for the sole reason that it gives them the ability to verify a certificate is in place. They can actually get a copy, as it were. That becomes valuable. But that is true. I'm not sure exactly how Ralph planned to handle questioning. If you have questions now, I can take some of them, or we can do a panel.
We can open some questions up to UL right now, and then afterwards, after everyone's done, we can reopen it again. So if there are any questions that you have for UL regarding a certification program, regarding a local certificate, now's a good time to ask. Questions on UL, how a product is listed, not listed, unlisted.
All right. Well, why don't we roll through the next speakers and so on, and off we go. Thank you.
Thank you. The next person that we're going to have is Tom Minerich. He's from ESL Corporation, a manufacturer of smoke detectors. We're going to cover some fire alarm technology. It's got some transparencies on it, going over the basics, also onto the new systems as well. Tom?
Thank you. I see some familiar faces from the New England Association of Fire Marshals meeting in September. Again, those who don't know me, my name is Tom Miners. I'm Northeast Regional Manager with Electro Signal Lab. We're located in Hingham, Massachusetts, formerly of Rockland, Mass. We started our company in 1966, pioneering the photoelectric market. Approximately 5 to 6 years ago, we got into the panel manufacturing market, and we've been progressing steadily every year so far. We have a new panel in the back room here, which I put on display for you to see. It's came out about 2 years ago. We've just really started marketing it this year. It has a lot of features, and I can go over that later on if you'd like to hear about it. Today I'm here really not to talk about smoke detectors, but to talk about fire alarm control technology, and basically where it was in the last 10 years or so and where it's going to go. Fire alarm control is a conventional design. Basically, it has two sides. One is your initiating or activating devices, anything from pull boxes, stations, smoke heat, flame detector, water flow auxiliary systems such as halon, CO2, cardox, anything that feeds an input into one side of the panel. I've brought a few drawings here with the printed machine on. Just give you a basic idea of a wiring circuit. Get this right side up here. And it's just a regular, most of you probably know it as a Class B system with an end-of-line device. I think in some of the municipalities, everyone seems to be different, or a lot of them do, depending upon. I handle the northeast part of the United States, and it seems like every area you go into have different code requirements. This is a Class B system. A lot of people require a Class A type situation. I'll leave that up there for a minute. The other side of the fire alarm control panel is the indicating or signaling side. Again, anything from bells, horns, chimes, speakers, the visual part of it, which would be the lamps, strobe lights, and beacons. A lot of different things you can add to that side of it. Also, they can be varied. In the smaller panels, which you're seeing a lot of today, the smaller panels are coming with two signaling circuits. This shows you two signaling circuits used in a small fire alarm control panel, staggering the horns down a common hallway, allowing you to have the first horn on one circuit, the next horn on another circuit, the next horn on the other circuit. Basically, it's a fail-safe mode, so if you lose one signaling circuit or one goes out, you still have horns going down that hallway. This is really the best application for that type of installation. I'm going to save this last for transparency until I get to another part here. There are other designs for signaling circuits. We also are capable of taking a signaling device, such as a horn or a strobe light, and putting it on the same circuit with a smoke detector. This is a fairly new way of doing it. It's not that new. It's been around for about 4 years, 5 years. And what it does is it offers a smaller application or a retrofit situation where you're in an old school, for instance, and using an old situation where there's an old wiring and you want to retrofit, put some smoke detectors in the back of the building. There's really no way of getting wire there, and it's cost prohibitive. What you can do basically is put in a circuit that's capable of carrying smoke detectors and horn strobes on the same loop, and be able to put smoke detectors out in the back of the building where before you couldn't do that. And what it does basically, it reverses polarity on the loop, polarizing the horns and causing them to go into to sound. And these smoke detectors are non-polarity sensitive, so they don't see the change. There are two simple circuits for this. One is doing it this way, and the other way it actually takes the voltage from the signaling circuit itself within the fire alarm control unit and applies the signaling circuit directly to the initiating loop, which is done within the panel itself. It might seem a little strange to some people because you're probably not familiar with that actual application. There are other simpler ways of doing this which are used every day. A design which basically will allow you to take one device, a standalone smoke detector, and it'll create a standalone smoke detector or with a horn battery backup, a system heat detector, and a system mini horn. And really you're just putting in one smoke detector to do all three of these functions. And because of, I know it sounds a little crazy, but it's true. If you took a smoke detector with an isolated thermal in it, we make a 445 CSH unit. We're not the only one that manufactures a smoke detector like this. But what you can do is you have an isolated heat detector in this unit. That will be tied into the hallway loop of the fire alarm system. The smoke detector itself will be powered up through regular 24 volts from the control panel. When the power is reversed, going out to the smoke detectors, when an alarm is seen in the common areas, it'll reverse polarity, causing the mini sounders within each one of the horns to go into alarm. So now you have a mini sounder. But if the smoke detector in the room activates, it does nothing but activate itself. So it's good to give you a battery backed up smoke detector, which I think you're going to see more and more of in smaller applications, or in a hotel motel application where you want to get that room detector, but you want to have that battery backup, not just an AC product. It's one way of doing it. And I can get into it in further detail later on. I have some drawings and stuff I can give you and showing you how to do this. You'll see more and more of these. I know a lot of them are being installed right now. The operation of the signaling devices, they change a lot. The constant signal on the audible, a march time, 120 pulses per minute, usually about the average. Audio evacuation, or a pre-recorded or tape message, or a digital synthesized voice. Breaking up of zones, which allow you to go floor above, floor below. A coded operation, which will give you a location of your initiating device through coded, basically a pull station. You're all familiar with the coded pull stations. And control panels have auxiliary functions, remote enunciation. Really three basic types: the old drop flag type, which I'm sure they're still being used in a lot of old installations, the bulb or incandescent type enunciator, and the LED, which is now really far better than it ever was before. They're supervising LED enunciators. They're a lot brighter, they last longer, and they're doing them backlit, so they're very clean compared to what they used to be. Control panels have auxiliary functions. Some examples of this are water supply tampers, a gate valve. Now they should be connected on their own zone. Most panels now are offering the ability to be able to have a secondary zone for gate valve tamper, strictly to give you a trouble indication, and this is it's almost mandatory now. The older panels don't have this. I think when you see a retrofit, you'll see this done in almost all cases. At one time, what they did was tie in the gate valve tamper behind the water flow switch. You're not seeing that anymore. Low water trouble, low air pressure in dry systems. There's an action relays, elevator recall, close fire doors, turn on smoke or exhaust fans, pressurized stairwells, operate auxiliary systems, water flow deluge or pre-action, release chemicals for firefighting agents, operate access strikes, door strikes, and things like that to allow people into the building. Some of the new functions you're going to see in some of the panels, which I'm sure you're seeing every day now, the ability for one-man walk test. This gives a technician to go out into the field with the local fire official to do the test on the system. He can do a true functional test of the smoke detector without having to run back and forth to the panel. I'm sure you're all familiar with that, having to go back to the panel every time, reset the panel, run back out to the smoke, back and forth, back and forth. Well, the new ones now will allow you to actually just go out, test the smoke, give you a blast of the horns, tell you it's all set, it'll reset itself, you go to the next smoke, they'll do the same thing. It gives you a positive identification the smoke detector is working. Alarm verification. This will basically resets the initiating loop. It notifies the panel and puts an alert in the panel that it's received a pre-alarm already. It gives a countdown and a wait. If an alarm comes in within the next 30 seconds, it'll give you another alarm. It'll actually put the panel into alarm. After a 2-minute cycle, in ours, for instance, it'll go back into its normal state, and it'll start all over again. Today, a lot of the panels are microprocessor based. The technology is moving forward every day. I was in London at the IFSEC show, International Fire and Security Conference, about a year and a half ago, and it was absolutely amazing the difference in their technology versus the technology here. We're just getting into where they've been at for a number of years. Most of the systems over there are microprocessor based. They use a analog or a addressable type of system, and which I'll get into here. The the two common ones right now are, one is the addressable, which you're seeing more and more of. Basically what that does is gives you a point identification or an address of each device out on the loop. And basically what you're doing is you're running out a continuous line, and it's pulling a line and it sends back its location and tells you exactly, you look it up, you can either look it up on a card, and the next card or something tells you where the device is. It saves a lot of time. Analog or smart technology is coming down the road. It's probably, let's say, 5 to 10 years away from really being there full time, but I do believe that's where it's going to go. Smart technology basically lets the panel know that the smoke detector is in trouble before it goes into trouble. If the detector starts going off, it starts losing its, changing, altering its sensitivity by getting dirty or falling asleep, it'll let the panel know. Okay, and now it's going to report. It's going to have a report function that when you run a report, or you program the panel to basically give you a trouble indication to let you know it's time to do service. And if you in most of the larger systems which are available today, I know Gamewell makes one, Simplex makes one, Edwards makes one. They actually run an entire program which will give you a printout of exactly what condition that the smoke detector is in. The microprocessor-based panels are capable of doing almost anything. Remote, if you were using a common control area and you're remoting CPU or remote control panels, what that allows you to do basically is have small fire systems all over a complete building, and if there's a break anywhere in the system, that little fire system will operate on its own. It's far different than having a high-rise where it has one common control unit, and if that common control unit's cut out, the whole system's down. Whereas with the new ones, if you put a CPU on every other floor, if the common control is out, it really doesn't matter. The system's still going to function, the fire alarm's still going to come in, it's going to transmit, it's going to evacuate the building, and it's going to save people's lives. In the years to come, you're going to see a lot of changes, I think, going towards the microprocessor-based technology. And a lot of the operation, too, is regarding the smoke detector having the opportunity to be adjusted in the field. I think this is something that you're seeing a little bit of. Pyrotronics has a system which is capable of adjusting the smoke detectors in the field. It really doesn't do a lot right now. I was with Pyrotronics for some time, and the problem is that with this technology in the United States, you're not capable of adjusting the smoke detectors to any degree to cause any major difference. You still need to get in there and clean the smoke detectors when they're dirty. You can't alter the sensitivity. I think that really that's basically it for control panels and where they're going. Microprocessor technology and analog technology, or the smart systems, I feel is probably where we're going to be at in the next 10 years. The other thing I really want to touch base on quickly was duct smoke detectors. I've had a lot of questions about duct smokes. A lot of people are interested in what the requirements are. And I saw one on one of the blue sheets in here. Any unit that's 2,000 CFMs or a 5-ton unit is required to have a duct smoke detector in it. I brought one with me. There's one in the back there if you want to see it. Basically take a look at it. Any unit that's over 15,000 CFMs is required to have one on the feed and one on the return side. I saw a write-up on the VOCA code that said any unit returning more than 50% of the outside air is required to have one on both the feed and the return side also. Most duct detectors operate from about 300 to 4,000 feet per minute, sensing air in an air handling unit. There are some that go up to 6,000. The actual duct detector itself only samples about 10% of the air passing through it. We have a pinwheel on ours, which is an interesting device which allows you to actually see the air moving through the duct detector. The problem with some of these cases is that the air in this air handling unit moves so slowly that it takes 50 feet per minute to even move that pinwheel. So you're talking about 500 feet per minute in the duct itself. So once you get down to 300, forget it. You don't even see the thing move. And that's really it. That's basically what I wanted to talk about. And I want to thank you for having us here.
very much, Tom. The next person that is going to speak is NFPA, National Fire Protection Association, which will be on some standards and some upcoming changes that we're going to have.
Thank you, Ralph. When Ralph first asked me to come down here and talk a little bit about NFPA codes and standards and testing and maintenance, I figured there wasn't really enough time to handle everything under a 20 or 30 minute period. So since Ralph had handled some of the testing and maintenance, I'm going to try to concentrate a little bit more on the codes and standards. Hoping everyone can see that back there in the back of the room. Part of the NFPA service that we have a free advisory service for anyone who's using the NFPA codes and standards. If they have questions on them, they can give us a call, and we'll answer their questions or try to make interpretations for you. So if you're an installer out there, or if you're the fire service, if you have questions on the codes and standards, please give me a call, and if I'm there, because we do travel a lot, we'll try to answer all the questions you have and interpretations for you. I see someone laughing over here, probably tried. Yeah. It's not that easy. We do travel quite a bit. Very difficult. Yeah. But don't give up. Keep on trying, though. There are several NFPA codes and standards, and we usually refer to them as the alphabet series of standards, 72 A, B, C, D, E, F, G, H, which I haven't listed. There's 71 and 74. I tried to put most of the commercial type of standards up here, which are these, and there's 74, which deals with the residential. I put at the top installation standards because the NFPA 72 series of standards and 71 are installation standards. I see a lot of people when they call up want to know what is required for, let's pick a restaurant for instance, what is required for a restaurant or fire alarm systems. These standards, 72 standards, are not going to tell you what those requirements are. These are purely installation type standards which have installation requirements, maintenance requirements, and use type requirements in there. So if you're looking for what's required or when is a fire alarm system required, you've got to look at the life safety code or the building codes. Okay, so that's one of the major differences between the 72 series and the life safety code or building codes. NFPA 72A, Local Protective Signaling Systems, is kind of your generic system. I would say most fire alarm systems have a 72A type of system or a portion of 72A in it. That means that the alarm signal does not get transmitted off-premise. It stays at the local premise for evacuation of the occupants. And that's a Local Protective Signaling System 72A. NFPA 72B, Auxiliary Signaling Systems. The alarm gets transmitted off-premise. Basically, the control panel at the protected premise is the same as 72A, except the alarm gets transmitted off-premise to the fire department through the municipal circuitry through a master box. Remote station, again, similar to a local system, except that the alarm gets transmitted to a monitoring station, which is called a remote station. They, in turn, have to retransmit that alarm signal to the fire department. NFPA 72D, proprietary systems, and I'll show you some block diagrams of the various systems and what's involved with them. Proprietary system would be a system, take a Polaroid or a Digital, it's probably a better company. They have several buildings throughout the state or throughout a certain piece of property. They're going to be monitoring their own buildings at a central receiving station, usually a security station, a guard shack type of application. And they're monitoring their own buildings, so that's a proprietary system. 72E is the standard on automatic fire detectors, so if you have smoke detectors, heat detectors, flame detectors, or gas sensing fire detectors, which aren't used that often, 72E is a standard that's going to tell you how to mount them, how to space them, what do you do for vaulted ceilings, beam ceilings, high ceilings, how to reduce the spacing. 72E is a standard that's going to tell you how to do that. NFPA 72F, Emergency Voice Communication Systems, is a standard that's going to tell you the requirements for moving the people around the building, giving them some sort of voice instruction, stay there, relocate to a different floor, or whatever kind of instructions you want to tell them for an emergency voice system. And then finally, there's 71, which is Central Station Signaling Systems, which probably most people are familiar with. I'm going to be monitoring a building or Central Station is they don't have any vested interest in the building that they're monitoring. So they're a third-party independent company that's monitoring other people's properties. They in turn have to retransmit the alarm to the fire department. And as Peter had mentioned, there's two separate independent means of retransmitting. I'm not going to try to get into too much detail, but if you have any questions at any time about either what I'm presenting up here or any other standard that I'm not going to talk about, just go ahead and yell it out at any time you want. An NFPA 72A local protective signaling system kind of has the basic components of a fire alarm system. You've got a local control panel, which is going to have primary, secondary, and treble power supplies. So you have three sources of power for a local control panel. The treble power supply, which is going to tell you when you've lost power or if you have an open in the circuit, can actually be the secondary power supply, so you can get away with only two. You've got initiating devices such as smoke detectors, manual pull stations, heat detectors. There's also water flow, which we haven't mentioned over here. And the only standard, this is 72A, the only standard that contains any requirements for evacuation, so your horns over here, your indicating appliances. So if you have a system that has evacuation, you have either a 72A system or a portion of 72A for the evacuation. Again, alarm doesn't get transmitted off premise, it stays right here, local. That was 72A. This is 72B, auxiliary protective signaling systems. If you look at what's on the control panel, it's similar to the 72A. You have your primary power, secondary power, treble power, your alarm initiating devices, which are smoke detectors, heat detectors, water flow. What's optional, again, remember 72A is the only one that has any requirements for evacuation. So evacuation or your alarm indicating devices are optional for 72B. And now the main difference, really, if you want to look at the main difference between 72A and 72B, there are some other smaller differences. But it's the alarm gets transmitted off premise to the fire service through a master box. And that's the transmission of that signal, and that's what makes it an auxiliary system, NFPA 72B. NFPA 72C, remote station signaling systems. Again, at the local system, the local control panel, looks very similar to the first one, 72A. Alarm initiating devices, primary power, secondary power, treble power. Optional, although it doesn't say optional here, this is optional indicating appliances for evacuation. The alarm gets transmitted off premise to the remote station, which is doing the monitoring, through either telephone lines, which use the polarity reversal type system, or what's new to the standard now is also they can use digital alarm communicator transmitters, DACTs, or DACs, digital alarm communicators. The reason why they went to digital alarm communicators is that the phone company is switching over to fiber optics. Polarity reversal does not work over fiber optics. So people are coming into to their plants on a Monday morning, finding that their control panels are in a trouble condition. After they've examined what the problem was, they find that the phone company switched over to fiber optics over the weekend, so they've got no more communication to the fire department. A quick fix, if you want to call it that, was to include digital alarm communicator transmitters so that you can still use the phone lines to transmit the signals using digital communicators. A lot of people, I think, get confused with digital communicators and tape dialers. Tape dialers are not what's required by the standards and should not be allowed. There is no, well, 71 and 72C have requirements for 2 phone lines coming off the digital communicator, not one. And Peter before was mentioning listing. It has to be listed for the purpose. Listed for burglar does not mean you can use it for fire alarm. So it has to be listed for the purpose, 71 or 72C. It has to have 2 phone lines. Digital or the tape dialers are not allowed. And again, these are just going over to other protected buildings that they're monitoring. NFPA 72D proprietary signaling systems. They're monitoring all these buildings that are on their property. Inside the buildings, they have control panels that are similar to 72A or B or C. And in fact, they may be listed for all of them. They may be listed for 72A, B, C, and D. They're going to be transmitting their alarm signal to a central receiving station. They in turn have to transmit the alarm signal to the fire department through various connections, auxiliary, remote station, or through manually pulling a master box. They have printers to record the signals that are coming in and the change of status of all the signals. Now this is very similar to a central station, except that this portion, the central receiving station, could be the central station, and the buildings they're monitoring are not their own. And there are some other fundamental differences, but basically it's the same type of operation between 72D proprietary and 71 central station. Now, as you can see, that it does get a little bit complicated and a little bit confusing when you're trying to determine which NFPA standard pertains to a certain kind of application. You want to know what the requirements are. It's very difficult sometimes to pick the proper standard. Is it a 72A system, B, C, D, 72F? Is it a central station? The committee realizes that, and what they're doing now is they're in the process of recombining some of the standards. They're going to be recombining 72A, B, C, D, and F into one standard. It used to be in one standard maybe about 20 years ago, and they separated it out because they felt that the requirements were a little bit different, and each separate type of system should have its own standard. Well, they're going back, doing a 360 now, and they're saying each system does have some differences, but there are a lot of requirements that are fundamentally the same between all fire alarm systems. So why not put them back together into one standard, make it a little bit more user-friendly, more people will use them and understand what they're trying to do. So what we're presently doing, and this is going to be ready next summer, it's actually going to the NFPA annual meeting in San Antonio in May, and will be available next summer. We're going to be combining the local protective signaling system 72A, 72B, C, D, and F into one standard that we're probably going to call NFPA 72 protective signaling systems. It's going to have all the fundamental requirements up front. Format-wise, it's going to look like the Life Safety Code if you're familiar with that. Fundamental general requirements are going to be up front, and then you're going to have specific chapters that deal with local systems, auxiliary systems, remote station, proprietary. So as a first step, we're going to be doing this recombination, and then 2 years after, at least we hope 2 years after that gets published, we're going to take the rest of the standards, which include NFPA 71, the newly combined 72, 72E, they have one on automatic fire detectors, NFPA 72G on notification appliances, and this is a guide. It's not a standard, it's a guide to help you with the proper mounting and location of strobes, horns, bells, anything that's used for notification. There are guidelines for you in 72G. They're going to take our guide on testing procedures, which is 72H. If you're looking for a good comprehensive document for testing and maintenance procedures for fire alarm systems, you might want to take a look at 72H. What it is a compilation of all the requirements out of all the 72 series of standards. It leaves central station alone, takes all those requirements and puts them into one standard. So you don't have to jump around from a local system to 72E for the automatic fire detectors to proprietary systems. You have one standard or one guide that has all those requirements in there for you, and that's 72H. And they're also going to be taking the household fire warning equipment standard 74 and putting it into one standard. I've called it 72 right now because we don't have a name for it, but it's probably going to be the new NFPA 72 protective signaling system standard. To give you a little bit of a format or the outline of what it's going to look like, it's going to have a fundamental section, again, that's going to deal with the definitions, the fundamental requirements that all fire alarm systems have, power supply requirements. It's going to have a separate chapter on household. We weren't sure how to separate household out of this, so we're going to have a separate chapter for the household fire warning equipment. Protected premise, the requirements that you have at the protected premise, as far as the installation goes, it's going to have those requirements in a separate chapter. The off-premise chapter is going to contain all the technologies that are available for transmitting the alarm off-premise. Presently, we have the 72B with the auxiliary system, the remote station, which uses polarity reversal, digital communicators, 71 that uses digital communicators, multiplex systems. They're going to take all that technology and put it into one chapter called off-premise. Initiating devices is really going to be looking like the existing 72E, which is automatic fire detectors, except they're also going to be throwing in all the initiating devices, which include water flow, valve supervision, air pressure, temperature, anything that's used to initiate a signal, whether it's fire alarm or supervisory, is going to go into one chapter. Notification appliances, both notification for evacuation or trouble signals, any kind of notification signaling appliance is going to have its own chapter. And then finally, it's going to end up with testing maintenance for the fire alarm systems. So if you're looking at actually designing a system, you can almost pick chapter by chapter, pick out the appropriate requirements. And if you're the fire service looking at inspection and testing, you can go chapter by chapter and determine what the requirements are for the specific installation that you have. So it's going to be a lot easier for everyone to understand. Hopefully it's going to be make it a little bit easier for you people who are out there enforcing the standards. Are there any questions on the NFPA standards, either what I've gone over or things that I haven't touched on, whether it could be testing or maintenance or anything else that anyone has any questions on? No? Okay, if not, I guess we'll go on to the next speaker. And do try to give me a call if you need some more questions. And I'll try to.
Thanks very much. Our next speaker is BRK, and we've got two speakers. They're going to be covering on detectors, basics of detectors, photoelectric versus ionization. I know it's a long-standing issue. And also duct detectors. So if we could get Shelley first.
22 to WVZ-71
My
base.
name is Shelley Depew, and I'm accompanied by Arnold Arredondo. He's our applications engineer. Let me give you a little background on who System Sensor is before I go on. System Sensor is a division of BRK Electronics. Most people are familiar with the name BRK. They've been around for a long time. And at one point it was one big company. We're in the process now of differentiating our products and our markets. BRK is handling single station, residential detectors, fire extinguishers, flashlights, that type of product line. System Sensor is dealing with fire alarm system components. Not in the panel and of things, but in the components that make up the fire alarm system. Smoke detectors save lives. I'm going to talk to you basically about the different types of smoke detectors. So we have photoelectric and ionization. How ionization detectors work. Basically, this is a picture of an ionization chamber. It consists of americium-241 and two electrically charged plates. What happens here is a radioactive source ionizes the air between the plates, making it conductive and creating a voltage. You see the voltage on the right there. Okay, when smoke particles enter the chamber, they attach themselves to the electrons, causing a decrease in the measured voltage, which causes the unit to go into alarm. One thing that Tom had mentioned earlier was a dual ionization chamber. A lot of manufacturers have gone to this technology for a couple of reasons. Here you have a sensing chamber and a reference chamber. And the reference chamber compensates for high temperature and high humidity. One of the biggest problems with ionization detectors is nuisance alarms caused by humidity. This type of technology tries to stabilize that by having the reference chamber and the sensing chamber. As you can see here, when there's clean air within the detector, the voltage remains stable. On the left, when smoke enters the chamber, the voltage decreases and causes the unit to go into alarm. It's also important to note that even though some of the ionization detectors are using the dual chamber, they're still susceptible to humidity, dirt, dust, insects, all of the things that were mentioned earlier in terms of nuisance alarms. It doesn't mean that they're not susceptible, it just means that some compensation has been made to reduce the susceptibility. Okay, photoelectronic detectors. Okay, photoelectronic detectors, what we're looking at here is what we call the light scattering operation. It employs a light source and a photosensitive receiving device, which is usually a photodiode. It's normally arranged so the light is not seen by the receiver. When smoke enters the chamber or enters the light path, a certain amount of light is reflected off of it, and a signal must reach or exceed a predetermined alarm point. In most photoelectric units, you're at about a 3% sensitivity. It has to reach that point before the detector will go into alarm. Another type of photoelectronic detectors is what we refer to as a beam detector. It consists of a high-energy infrared emitting diode, a photoreceiver. They're mounted opposite each other, and the light is monitored 100% of the time. Okay, when smoke enters the light path, it gets between the transmitter and the receiver, the amount of light is reduced below the alarm threshold, and the unit goes into alarm. This is an example of an application for a beam detector. It's an atrium. Okay, if you have an application where you have a very high ceiling, it may be difficult to use a standard open area smoke detector. The reason for that is that it takes a higher thermal lift to get the smoke up to the detector because you're talking about a greater distance. In addition, maintenance, testing, cleaning are much more difficult when you're dealing with a high ceiling. So a beam detector would be more applicable. A lot of the smoke detectors on the market today, only in the photoelectric, are using what we call signal processing. Typically what it does is it pulses every 8 seconds. When it sees smoke, it begins to pulse every second. And it needs to see smoke for 3 consecutive 1-second intervals before it will go into alarm. This again is some technology that has been put into photoelectronic detectors to improve the nuisance alarm. So it doesn't go into alarm as soon as it sees the smoke. It has to, first it sees it, then it has to see it 3 more consecutive times before the unit will go into alarm. Okay, 4 stages of a fire. When we talk about the difference between photoelectric and ionization and what is more applicable to what type of fire. Incipient stage is the beginning stages of a fire. Ionization is usually the most effective due to the particle size, and we'll talk a little bit about that more later. When you get into a smoldering fire, photoelectric detectors are more ideal. Example of a smoldering fire would be a cigarette on a bed, on a couch, fabric that's going to produce that type of smoke. Ionization is going to detect more of a fast flaming fire, very common for chemical fires. Or computer rooms where you have electronic components. They're going to produce a quick flaming fire. You're not going to get a lot of smoldering smoke. Third stage is the flame. Different options here. You can use a flame detector, which usually employs either ultraviolet or infrared technology. And in some cases, photoelectric and ionization could be applicable. It all depends on the ambient conditions. And then the fourth stage of a fire is heat. Heat detectors are available in either fixed temperature, radarized. Typically, they've been mechanical, and coming out on the market now are electronic heat sensing detectors using thermistor technology. And you'll see more of that as time goes along. Obviously, it's believed to be more reliable because it's electronic versus mechanical. Okay, this is a color of smoke curve. And if you look at the ionization line, okay, you can see that ionization is very sensitive to invisible smoke. and then as it goes down, it becomes less sensitive to black smoke. Whereas the photoelectric detector is insensitive to invisible smoke and dark smoke, but right in the light smoke areas where the photoelectric detector becomes more efficient. Environmental conditions influencing detector response. When you're using an ion detector, things that you need to concern yourself with are air velocity, atmospheric pressure, humidity, and temperature. With photoelectric, the key things are humidity and temperature, and with the beam detector, humidity and temperature. And color smoke with photoelectric as well, because as I said earlier, it's the light smoke that the photoelectric responds best to. Then when we look at the real-world environment and the things out there that affect smoke detectors, here's a short list of some of them: dirt, dust, heat, cold, dry, humidity, dark, light, insects, vandals, etc., etc. These are the things that we need to concern ourselves with when we decide what type of detector we're going to use. We got to look at the real-world environment, and we got to look at the type of fire that's going to be produced, and that way it helps you decide whether photoelectric or ionization would be more applicable. I'm going to hand this over to Arnold, who's going to talk to you about duct detector technology and application, and then I'm going to come back and go over maintenance and testing.
I've been told we're running a little late, so I'll forget the introduction and go right into smoke duct detectors. Basically, as Pete from UL already mentioned, there are two types of standards. There's a 268 standard, which is the commercial standard for open area smoke detectors. There's a 268A standard for smoke duct detectors. This smoke detector here happens to be a 268A unit. This is a 268A duct detector. Typically, it's using duct detectors typically use a commercial smoke detector within a housing. Smoke duct detectors come available ionization, photoelectric, 2-wire, 4-wire, AC, and DC. So it's important to look at the labels on your duct detectors when they're being applied and tested to make sure they're wired properly. It's important to note also that the duct detectors should not be used as a substitute for open area detection. Detectors are not to be used as a early warning detector, and duct detectors are not to be used as a substitute for a building's fire alarm system. Some of the has been already mentioned, but some of the basic applications or requirements for duct detectors is that any system over 2,000 cubic feet per minute has to have a duct detector, and it must be installed on the supply side. If it's a duct detector, or if it's a system over 15,000 cubic feet per minute, you mount the duct detector on both return and supply. If the system happens to be under 15,000 cubic feet per minute, and if the building has a regular fire alarm system, and the ventilating system, which is also served in that building, you can eliminate that duct detector. And this is right out of NEMA manual and proper guide for smoke duct detectors. When there's an approved fire alarm detection system in the building, smoke duct detectors should be connected to the building fire alarm system, so that the fire alarm audibles will sound when upon the activation of a smoke duct detector. So if you're inspecting duct detectors and if they're used as standalone devices, when there's a building fire alarm system in the building and the HVAC guy comes in and installs the duct detectors, you have to make sure that duct detector is wired back to the control panel. When duct detectors are used as standalone devices, they have to cause a local audible to sound in a normally occupied area. In addition to the local audible for alarm, you have to have some form of trouble condition enunciated also in an occupied area. The trouble condition can be either audible or visual. When applying duct detectors, in this particular application, the system is over 15,000 cubic feet per minute. The installation is both on a return and supply. When you mount duct detectors on the supply side, you always want to be downstream from the filters. And on the return side, you have an option of mounting either after or before the return air fan. associated with the duct detector, which penetrate the duct so that when air flows into the holes through the compartment where the smoke detector is mounted and back out the exhaust. When you reach lengths of 3 feet or longer on your sampling tubes, it is recommended that the opposite center of the tube be supported. It is also acceptable to mount open area smoke detectors in the duct, but they have to be listed for the purpose. I'm only aware of one manufacturer right now that has an open area smoke detector listed for this particular application. There are some problems associated with this installation. And one of them is, first of all, if detectors are exposed to direct airflow, they have a tendency to act like a filter. They will pick up dust and lint much sooner than a detector mounted, say, in the ceiling of an office environment, and will have to be maintained more frequently. It's also important to note that when you mount a smoke detector in the duct, you also have to make it accessible for maintenance. An open plenum application, it's difficult to mount duct detectors. Typically, duct detectors are designed to be mounted on the surface of a duct. In an open plenum application, of course, there is no duct, and difficult to mount the duct detector. The installer has a couple options. You can either mount a duct on the opening of the return, the common return, or you may use a long-range beam detector mounted at opposite sides of the walls, shooting the beam across. And of course, if there's the area is duct, then duct detectors would be appropriate, as the diagram shows on the bottom. A lot of times people will ask, well, how many duct detectors do I need? Do I need one on a return in the supply, which requires 2 duct detectors? In this particular application, the standard says that duct detectors, that you should treat every smoke compartment as a separate area. So in this particular application, you need a duct detector on all 3 compartments. This is an example why a duct detector should not be used as a substitute for as an open area detector. It will give you a false indication. As to the level of obscuration in this particular application. When applying duct detectors, you want to look for any returns or elbows in the duct. It is recommended to maintain a 6 duct width distance if possible from these openings. Where it is physically impossible to maintain these widths, you can bring it in closer to maintaining maximum distance. Duct detector may also be used for auxiliary control. In this particular example, smoke has been detected by the duct detector on the return side, causing the return damper to close, the damper to the outside to open, exhausting smoke from the building. Smoke duct detectors can also be used for the purpose of exhausting smoke from the building. As you note, there are duct detectors on both the return and supply of every floor. Smoke has been detected on the 3rd level, causing the damper on the supply side to close, and the dampers on the 2nd, 3rd, and 4th level to remain open, creating a positive pressure and forcing smoke out the building from the 3rd floor. Smoke duct detectors may also be used for the purpose of releasing doors. In this particular example here, smoke has gone undetected and smoke is backfilling an area that could possibly use it as an area for refuge. Smoke has been detected either by an open area smoke detector or a duct detector, causing the door to close, creating a positive pressure in the area of refuge, and keeping smoke away from all the openings around that doorway. The doorway has been opened. The pressure is so great that it pushes smoke away from the doorway, allowing people to use that door as an area of egress. Open area smoke detectors, there are some specific requirements on how an open area smoke detector can be used for door release. And this is right out of NFPA 72E. I won't go into detail, but it's there for your use. When using smoke detectors, it is also acceptable to use open area smoke detectors for the use of smoke control. Typically, an open area smoke detector has a listing spacing of 900 square feet, which is 30 by 30 based on a 10-foot ceiling. When applying an open area smoke detector to a plenum, one has to consider the effects of high air velocity. And based on your air changes per hour or air changes per minute, you would want to reduce your spacing. In the chart above, if you can read that, we have air changes per hour at 8.6. Your spacing is allowed to remain at 900 square feet. As your velocity increases, you would want to reduce your spacing according to the chart there, either by 50%, 40%, 30, or 200. That's based on a 900 square foot spacing. When applying open area smoke detectors to a plenum, it's obvious that you want to install the detectors in a manner that is in favor of airflow. In this particular example, the installer has decided that the airflow in this application is in a funnel form, and he has placed more detectors towards the narrow end of the funnel for a better detection. On perforated ceilings, when you install your detectors, it's acceptable to mount a smoke detector above a grid, let's say, but you have to be within 24 inches of that grid, and you want to orientate that smoke detector over the grid so it's in favor of airflow. We have tiles here. One that happens to be 36 by 36. You'd only need one smoke detector above that tile. We have a second tile that is 36 by 72, and you require two smoke detectors to protect the plenum there. This is also right out of NFPA 72E. I kind of have a problem with this diagram here, but it talks about weak ventilation and strong ventilation. NFPA 72E says that if you're going to install a duct detector near a supply vent, you have to maintain a minimum distance of 4 feet. They are in favor of installing detectors on the return side and do not specify a distance. But from a manufacturer standpoint, I would try to maintain maximum distance from both supply, mainly from the supply, because for the reason that a detector will have a tendency to collect dust and dirt. Open area smoke detectors are the preferred method for control. Duct detectors are very unreliable. As some of the diagrams showed, there's a possibility of dilution giving the detector a false indication. Under energy management control systems, the system may be shut down and the space in the ducts would be considered dead air spaces and possibly not giving you detection. When you apply smoke detectors for smoke control, in this example here, it could be either a sheet metal roof or a high ceiling application. You can stagger your detectors, every other one lower down to 36 inches, the other one at the finished level, to give you better activation to vent up stratification. This is an example of a detector mounted near a return. It has worked in favor of detecting smoke. Again, a distance is not specified, but from a manufacturer standpoint, I would recommend trying to maintain at least a 4-foot distance from the return, because you don't want detectors to become false alarm problems due to dust and dirt collecting inside the units. In our industry, we commonly refer to 2-wire and 4-wire circuits. In the heating and ventilating market, many times the heating or HVAC installer has no concept of this theory. But a 2-wire circuit would be 2 conductors coming off the control panel, supplying power to the smoke detector as well as initiating the alarm on the same 2 pair of wires. There are many panels available in the market. It is important when you apply 2-wire smoke detectors or duct detectors to a control panel that it be found to be UL compatible with the control unit. March 1st of this year of '89, UL has come up with new requirements for compatibility, and they now require you to mark the control panel and the smoke detector with an identifier. So when you go out to inspect those duct detectors and you find out you have a 2-wire duct detector, make sure that the compatibility letter or number meets the compatibility letter or number in the control panel. 4-wire smoke detectors are exactly that. 2 conductors used for power and 2 conductors used to initiate alarm. 4-wire smoke detectors typically have integral relays. When the detector goes into alarm, giving you a dry set of contacts to trip the alarm circuit. This is happens to be a system sensor duct detector wiring diagram. And I just want to point out that on AC model duct detectors or duct detectors that are made for local power often utilize a supervisory relay. Many times the supervisory contact inside the detector is misapplied. This is the proper method to wire up a detector which uses a supervisory contact. Many times installers will try to save themselves some wire and they'll jump from the alarm contact right to the supervisory contact and form a loop, which is incorrect. NFPA 72A is clear that any devices that use integral supervisory contacts must be wired between your last alarm contact and the end of line resistor. Which I already mentioned, 2-wire smoke duct detectors or 2-wire smoke detectors must be tested and listed to be compatible with the specific initiating circuit. So it's not just the control panel, but it's also the initiating card. Smoke duct detectors, if they utilize pigtail leads, should not be wired in this manner. This is called as a T-tap connection. A duct detector wired in this manner would be wired up incorrectly, with the exception of intelligent systems where T-tap would not really matter, because if the device became detached from the circuit, the panel would see it missing from the circuit and go into a trouble condition. This would be the proper method of wiring up a smoke detector. You have your in and out connections, positive in, positive out, negative in, negative out. It is incorrect to loop the wire around the terminal. The wire can become detached from the terminal. The loop remains intact and not giving you any indication that the detector has become disconnected. Many smoke detectors and duct detectors utilize a clamping plate, or sometimes called a SENS plate washer. It is acceptable and it accomplishes the same task as in and out, either in and out pigtail leads or in and out connections. However, the wire must be cut clean and clamped down under opposite sides of the screw. In 4-wire installations, it's also important to note that power to the detector must be supervised. And often in duct detectors, when you have multiple units on the circuit, they fail to use a end-of-line supervisory relay. The detector can become detached from the circuit or power lost in the detector, and you have no indication in your control panel that a detector has been disconnected. So it's important to note that on DC 4-wire installations, that a supervisory relay must be used. Then we go to Shelley on testing and service.
Basically recommended that all smoke detectors be visually inspected semi-annually to identify for missing detectors, detectors which are no longer suitable for that particular location or application, detectors that have impeded smoke entry, and detectors which are abnormally dirty. All smoke detectors must be tested annually in their installed locations with smoke or aerosol, whichever is acceptable to the manufacturer. Aerosol right now is a very controversial issue with smoke detector manufacturers. System Sensor's position on it is that we prefer that you use real smoke, either burning rope or a cigarette. The reason for that is a lot of testing has been done on our particular detectors that shows that the aerosol actually disintegrates the plastic within the chamber. Okay, so there's reasons behind our preference on that. Okay, all smoke detectors must be tested to assure proper sensitivity within 1 year after installation and every other year thereafter. There's a couple different methods to do that. One is the Gemini smoke generator, which can be used on any smoke detector. That will measure for sensitivity. On system sensor smoke detectors, we have incorporated into our design a test port which you hook up a meter to and a voltmeter, and you get a correlation as to what the sensitivity is. So you can actually tell what the exact sensitivity is while you're in the field. If you have any questions on that, I can answer that later for you. I have some samples in the back. Detector test log 72E requires that before final inspection, the contractor furnish a written statement that detectors were tested and installed in accordance with the manufacturer's instructions. This is an open duct detector. When you're inspecting and testing a duct detector, recommend that you inspect the filters, you inspect the sampling tubes, check for impeded smoke entry, check for pressure differential between the tubes, blow smoke at the head, do a smoke entry test, check for wiring and supervision, and either use a magnet test or a green card test, which is common to the BRK detector, or whatever test is recommended by the manufacturer. It's important to keep in mind that although detectors are good under the worst conditions, they are still susceptible to dirt, water, humidity, and they must be kept dry, they must be kept clean, and they must be kept free of bugs. Fire alarm system logs should be kept at all times. Okay, this is an example of the chamber. We recommend you visually inspect it. Look for the obvious. A lot of times you open up the detector. Most of the detectors on the market are very easy to open up, very easy to clean. Just visually look at it. This is the bottom of the cap of the detector. We recommend that you take that off and you blow it out with either compressed air or a vacuum to get the dirt, dust, bugs out of it. Again, look for the obvious. Here we have insect droppings, a roach in the middle of a chamber, corrosion on the metallic parts of the detector because of high humidity, for example, spider webs. Okay, all four of these things produce nuisance alarms, and a lot of it can very easily be prevented by just opening up the detector semi-annually or annually and visually looking at it. That's about it. That concludes BRK's end of this. Thank you.
I have one question I can ask you.
Yeah.
How is it that BRK right now is recommending that the detectors be tested with smoke, or even ESL for that matter, whereas in the past ESL would recommend testing with the magnet, or in your case you say a green card. Don't you feel confident that your recommended test procedure is going to work in the real world?
We do. On our detectors, we have what we call the green test card, which is really a go, no-go test. We also have a test point, which is similar to a magnet test. It's a fully functional test. But what we're finding out there is that a lot of the authorities having jurisdiction are requiring that you test for smoke entry.
Have you ever known of your test to work and for smoke to not cause a going alarm in a test?
No, not that.
It's not been a problem. UL and 268 specifies any test feature provided on the smoke detector must electrically or mechanically simulate a specific percentage of smoke. And in the 268 standard, it happens to be 6%. So when you apply the magnet, a test switch, the green test card, or the reed switch, electrically in functioning, you are determining that the detector is capable of sensing smoke. However, let's say somebody took masking tape and masked off the detector, the unit will still function with the green card or with the magnet test. So there is
Except that's visual. You can see that.
correct. So visually that's obvious. So that's why we're taking the stand that you should visually inspect the smoke detector as well as testing it with the tools or the methods that we recommend.
All right, I'm going to put you on the spot here. Would you say that, I don't see how you might not be offensive saying it, but you feel that using smoke there are many people in here, I've been in many meetings where they will insist on using smoke detectors. Is your opinion that's totally unnecessary?
I don't think it's totally unnecessary.
Given the visual part of it, notwithstanding.
I would say there is some value to it. There is some value to smoke testing. However, if the detector has been visually inspected, and if the detector has been tested with the magnet and with the green test card, then there is no need to test the detector with smoke. Okay, but if you don't test the detector with the magnet or with the card, then smoke would be an alternative.
Only your test procedures are more accurate in terms of determining sensitivity than smoke is, because you can actually put so much smoke in there that it's way over what it's supposed to be.
Right.
So smoke is not a really accurate way as much as what's recommended by the manufacturer in terms of using the magnet and duplicate the 3.3%, whereas smoke you can end up having 50% before it actually goes into blast. They're very desensitized before it's sensitive to smoke.
Actually,
That's correct.
an FDA has an interesting point. They suggest too.
There are, NFPA recommends that you do a functional test with smoke or aerosol acceptable to the manufacturer to make sure that smoke can get into the chamber. If a smoke detector were on the ceiling, and I've seen this happen, when you try to put smoke in it, the airflow in that room could be such that the smoke does not enter the chamber of the smoke detector. It'll just take it away somewhere else. So that's one way that smoke may not get into the detector on the ceiling because of airflow. And another one is that dust can get into the bug screen and into the detector and impede the flow of smoke going into the detector. So that's the reason why we require a functional test with smoke or aerosol, is to make sure the smoke can actually get into the chamber.
I've seen it though where they test with smoke, and there is so much air going by it that they have to hold it right up next to it before it actually senses the smoke.
That's right.
So I mean, they're not observing the problem there. The problem is that there's too much, the velocity is too high to be realistic for fire.
That's right, and that's what you're finding by doing a functional test with smoke. You're showing that the airflow in that room is such that the detector's never going to see it. So you either have to do something about the airflow or probably change the location of that detector. And that's why, just by pressing the test button or using the magnet or the green card, yes, that'll give you a functional test of the electronics, but whether or not smoke can actually get into the chamber might be a different story.
The point, too, that he was making, I think, was that you could take a can of the aerosol and stand up and spray the whole can of aerosol, and eventually it's going to go into alarm. That doesn't mean that at 3% of that aerosol it's going to go into alarm. There's no measured amount of smoke that's going in there. It doesn't tell you that the unit is within sensitivity range.
Could I bring you back to your remark in reference to the aerosol spray can that you have experienced a deterioration of the plastic in your units?
Yes.
Could you highlight that briefly?
All I'm aware of is that a lot of testing has been done. I know on the BRK unit, and I think on the Fenwal unit as well, because it's the same plastic, that continued use of the aerosol causes the plastic to disintegrate.
We've also found the same thing. We have samples of it, though.
So BRK and ESL is saying no sprays
No
allowed.
spray.
Right.
I'd like to make one other point, perhaps the gentleman from ESL will make a point on exactly what T-taps are as briefly as possible and what the implication is out in the field, when what a T-tap is and what the danger of a T-tap is.
I'm really glad you brought this up. I just inspected the system, as a matter of fact, the day before yesterday, and oddly enough, it was all T-tap, the entire system. And basically what it is when you T-tap a system, the smoke detector will function, but the smoke detector is not supervised. You're getting a false sense of supervision because there's no way that you as a fire official are going to be able to tell that that system is supervised or not supervised from a visual inspection or from operational inspection. You may go out there and you'll find that the smoke detectors look great, there's an inline resistor, the panel reads resistance on it, everything seems to be just wonderful, but halfway down the middle of the loop somewhere, somebody's T-tapped off and has 2 heat detectors or a smoke detector. Now, they look good and everything, they'll function and everything, they're not supervised. You lose a wire, no one will ever know. The system will not function. Those devices could be dead and no one will ever know.
The system won't go into trouble, in other words.
Correct. It will not go into trouble. You can lose that whole loop, broken right off, you never see it.
There's a bigger problem than that.
Correct. Yeah, but what I'm saying, providing you tested, you don't know what if a fire, what if you have a problem, somebody's in there working, they cause a problem, they cut the loop off, and what their work caused the fire. You you have a fire and no one will ever know. And it's not tested in time.
It's a bigger problem than that. Put a system into a place like a dormitory or a frat house or an apartment house. Someone pulls down the smoke detector somewhere on the system. You'll never know it because you'll never get a trouble signal. You don't know that every device is still on the circuit.
Absolutely.
That's more important than
Sure.
breaking a wire, because that happens very seldom. What happens more than often, we go and we find smoke's missing and no trouble signal.
Right.
Why systems should be tested for both alarm and trouble during the acceptance and during periodicals, to make sure that no changes have occurred that gives this lack of supervision. It's very important that it's done that way.
He didn't describe it.
Our last speaker today is from the Mass Property Insurance Underwriters. They're associated with the State Fire Marshal's Office, and they're going to be going over the Arson Watch program and how it relates to fire departments.
I'll condense 20 minutes into 5 minutes. My name's Ron Meehan. I'm the supervisor of inspectors for the Massachusetts Property Insurance Underwriting Association and the Rhode Island Joint Reinsurance Association, also known as the FAIR Plan. And part of our function within the last 5 or 6 years is to get involved with this Arson Watch Award program, which I think probably everyone in this room might have heard of. As you came in, there's been a packet put together here that looks something like this. Okay. All the information basically I was going to go over, but for the sake of the restrictions on time, take something home, look it over. If you're not aware of the program that we've been working with the fire marshal on, it's been a big success. It really works. I just had an opportunity to talk with a detective out in Haverhill, Lawrence, 2 weeks ago. And we were able to award an individual $2,500 for information leading to the conviction of a person involved with setting a fire out there. Over the last 3 years, Mr. Ed Silk has retired, and he was actually this was his main function over there, along with being the personnel director. And sometimes when someone goes away these days under Proposition 2.5, I'm sure you people can relate to this. They don't replace an individual. They just kind of take this cap and put it on someone else's head. So there's an individual in there now, Jack Olimbesky, who's the president and general manager, who's wearing 2 hats now. Okay, he's also supposed to be running the Arson Reward program and running the operation also. Jim Pappas, who is the underwriting manager and now VP for underwriting, was supposed to be here today, and unfortunately, due to other circumstances, he wasn't able to come. So they pulled me out of the trenches. I'm just the guy that works on the road occasionally and does the inspections in your lodging and your boarding houses and your large risks. So I'm kind of like the front line. Those guys are all the executives. They work behind the desk. I'm out there in the street like a lot of you people are. We have a total of 5 inspectors that work in the Essex County area. They work directly for me. Back in 1980, I worked for the ISO at that time. The FAIR Plan was having problems with the types of inspections that was being done. Every piece of property, regardless residential, commercial, whatever it is that comes into the FAIR Plan, we respond with an inspection. Well, in those days, we were farming out the inspections. It left a lot to be desired. A lot of inspectors were not getting into the property, were not getting the quality inspection that we needed to properly underwrite that property. So a pilot program started. That's when they pulled me from ISO, and we went over and I started the inspection program. Since that time, we have really reduced, okay, number one, the amount of claims. But what is really a concern to you folks is the fact that we have communication between the fire service, the police service, and the insurance industry. I personally have always felt that when I go out and I look at a piece of property, yes, I'm there for the insurance industry, granted. But besides that, I feel as though we have a sense of responsibility to the individuals that are living in that house. okay? I know a lot of people look upon the insurance industry as being cold, okay? We go out there and we're just interested in one thing, okay, the premium dollar. But it's unique working for the FAIR Plan because we don't look at things like this. Our losses are shared by all insurers within the state of Massachusetts and Rhode Island. So I have no benefit to go in there and do a shoddy inspection. I want to go in there and do a good inspection at that property. And having our own pilot program started and having our own, we don't have to have third-party inspectors now. We have good control over the quality of inspection that's being done. As I said, I have 5 inspectors that work in Essex County. And they report directly to me. I'm going to give you an 800 number before I'm through here. And I'd like you to take this 800 number down because we can work together here, all right? Information, passing information back and forth. I would say because of the setup the FAIR Plan is, we get the types of property that the normal market doesn't normally want to write. Okay, call it the pool, call it the risk pool, whatever you want to call it. Back in the 1960s, during the Watts riots, it became necessary for the federal government to step in and form some type of an insurance pool so that people that had sound property could get insurance somewhere. And that's when this was formed. In the early 1970s, this was enacted in the state law here in Massachusetts and in Rhode Island. In Massachusetts, it was deemed that the entire state would be able to be eligible for this, not just the urban areas. So basically, that's what's taken. 2 years ago, when the federal government couldn't carry the crime insurance any longer, we took on another cap. All right, we are now the mass crime insurance program. So these alarms, all the discussion about alarms today, I found very, very interesting. We don't have the number of crime insurance policies that the federal government had at that time because most of the residential people were able to be put right into our homeowners program. We're the largest homeowner insurers in the state. Yes, sir.
Hey, I got first of all, a 1-800 number. Everybody's waiting for it. Because
Okay.
I like to call the insurance company.
It's so 1-800-392 1-800-392-6108, and my extension is extension 230. Everyone have that? Now the reason I gave you that number was to utilize it. Okay, I'm a pretty friendly guy. All right, I'm a people person. I want you to call me. I want you to ask me questions. Hey, I have a building. If you're in fire prevention, I have a building over in such and such a street. Okay, I know this, that, and the other thing about it. You people insure that building? Okay, we can work together here, and I think it's.
I just got a question for you. But you said you have most homeowners policies, you know, with more so than anything else probably.
Right.
Why is it that the insurance companies, I'm from the fire service, as you can see, take away, you have to pay more money if you want residential sprinklers in your home, which will save your life. And 80% of our fire deaths are in residences, not in buildings, commercial buildings, that most of the insurance companies want to protect because they don't want that big loss. It was stated here earlier, the fire alarm people are here for life safety. Besides, and I put it to myself, they're making a buck out of it. But the insurance company people, to me, aren't here for life safety. They're here for building safety. And you would think if they were for life safety, they would give a lot of people, like a fire chief from Middleton, a break in a residential sprinkler system where they told him it's going to cost him more money if he puts a residential sprinkler system in his house because of water damage. Because they don't give a, you know what, about life safety. They care about building loss. Can you bring that back to your bosses and ask them why it is that way?
And I like that type of input because that's why I'm here.
That was the one I was talking
Okay?
about earlier.
It works both ways. That,
The premium didn't
to
get
answer your question, okay, that will be brought back, okay, and it'll be brought back to the Insurance Rating Bureau, or the ISO as we know it today.
Can we get a report back from that to let us know what's happening?
Absolutely. Let me just remind you of one thing. We are probably the only insurance facility that does home inspections, both interior and exterior. A lot of insurance companies will do what they call a ride-by. Okay, some will do what they call an E&O report. Okay, but most of them do what they consider just ride-bys. But by the nature of the business that we get, and believe me, not all properties that come into us are substandard because we don't insure substandard property. We don't insure substandard property. Let me say that again. We don't. We go in and we inspect the heating system, the electrical system, the overall condition of the property, if there's fire damage, and the occupancy. We do a thorough home inspection. We also do a thorough commercial inspection. But here we go again. We're going to, okay, I have an allegiance to the insurance company. I really don't have an allegiance to the insurance company. And I'll tell you the reason why. Our market right now is so soft that our commercial book of business has been down, and it has been down for a couple, 3 years now, because that's the way the insurance companies work. But all indications are, and no one knows it better than the people in the fire service. I have a son that's taking a test next month, okay, and I'd like to see him get on the fire department. But right now, it doesn't look too good because of Proposition 2.5. So you have to utilize what services you get for nothing, and I'm a service that you'll get for nothing, okay. And I will try to answer that, and I will get back to Ralph on it, okay, and you put me in contact with one another, and I'll do the best I can on it. But just let me get this over with as quickly as I can. I'm Irish, so it's really tough, I'll tell you. The Arson Watch Reward Program, okay? If you don't know about it, please pick up the information that I brought into you. In this packet, you will find a white sheet of paper. On there's about, probably 6 or 7 items that you can order from me at no cost, fellas, no cost. Pins, okay, information on how you go about this program. If someone comes up with some information, your investigators feel as though that individual should be given some type of a monetary reward, it's put on an application. It comes into us, and it goes basically and briefly in front of a committee, all right? And they look at the nominee and what actually transpired, and they come up with a cash award for that individual. It's usually brought down to your either the fire chief, police chief, or whoever's in charge of the investigation, and a presentation is made, okay? And it's really a program that really works. As I said, if you have any other questions on Arson Reward, because of the time, just call me. But everything should be answered right in here. I just want to speak one more minute on the inspectors that work in this area. I will give you their names. They got answering service numbers. Okay? Call me. I'll be glad to do that. Contact them. You'll be talking into a machine that doesn't talk back to you very much, okay? Leave the information, or they will get back to you. That I can promise you. All right? Just briefly, since the lodging and boarding house fire that we had in Beverly, correct me if I'm wrong, 3 years ago, some July 4th, 19, whatever it was. Okay.
5 years.
All right, as soon as the bells go off and something tragic like that happens, all right, they're down. Jack usually comes down to me and say, what are we doing about things like this? And he'll throw the paper at me or something like this. And my job is to try to stay ahead of this. And I'm very thankful that I try to stay on top of it. About a year prior to that, we have a training program in-house that I've developed that usually runs for 3 weeks of classroom and approximately 3 to 4, maybe 5 weeks, depending on the individual out in the field. So at that time, I decided to kind of break the program, the training program, down into different areas. We started with residents, we went into different types of commercial occupancies, mercantile buildings, apartments upstairs, which has had, over the years, have had a high incidence of fire loss. The drugstore with the apartments, or the variety store with the apartments, whatever it may be. And then at that point in time, I branched off and went into a boarding and lodging house scenario, all right? So I started off with the videotape of that loss there in Beverly, where it shows the enormous fellow that came out that was burnt 90% of his body and he finally dies. That's how I opened this presentation up. Right away, I have my inspectors glued to the screen. All right, guys, you know yourself when you do inspections, sometimes you get very into this routine. You go through, you're looking at smoke detectors, you're looking at wires, you're looking at this, that, the other thing. You just get used to doing it, and it comes with the job. But by giving this presentation, I was able to draw off our computer all the numbers of lodging and boarding houses that we insure in the state of Massachusetts and Rhode Island. And I went out and re-inspected all of these properties.